Okay, here I want to take a look at Cohen's d. Now Cohen's d is a measure of an effect size, where an effect size indicates the magnitude or the difference between your groups. The effect size can be calculated, specifically Cohen's d can be calculated for the one sample z-test, the one sample t, the independent samples t, and the dependent samples t. So you're going to see it used for all t-tests and the z-test as well when that comes up. It can be used in other applications, but as we move to ANOVA, we're going to be using something called eta squared and partial eta squared. Okay, so for Cohen's d, there's basically these guidelines that Jacob Cohen himself gave when he developed this measure. And that's 0.2, 0.5, and 0.8, where 0.2 corresponds to a small effect, 0.5 corresponds to a medium effect, and 0.8 is a large effect. In the way we interpret this here, what does D mean? It really is like a z-score. If you recall z-scores indicated the number of standard deviations, the number of standard deviations a score was away from the mean. We're going to use that same kind of interpretation here. But what we're talking about here, like if we use the independent samples t-test, where we have two groups, a d is the number of standard deviations the groups are away from each other. Okay, because we have two groups in the independent samples t-test. So if we had a d of 0.2, that would mean there was 0.20 standard deviations, that's what SD stands for here, of a difference between the two means. D of 0.5 is 0.50 standard deviations of a difference between the two means, or in this case, 1/2 of the standard deviation difference. And then 0.8 is 0.8 of a standard deviation of a difference between the two means. Okay, so continuing with our independent samples t-test example, let's look at an example. Say we had our two groups, just generically here. We had M1 and M2, so the means for the two groups. And let's say that we calculated D and we found that it was equal to 0.50. And say that the average standard deviation for the two groups was 10. Okay, that's the average standard deviation for the two groups, so overall. And if we have a D of 0.5, we could basically say here, to give you a sense of what this means, is that there's 1/2 of the standard deviation difference between these two means. And if the standard deviation, the average standard deviation is 10, then what that's saying is that it's 1/2 of a standard deviation, or 10 points, between the two means, or that would mean that there's a 5-point difference between these two means. Okay, so this example here, you don't have to do this yourself, but I was just trying to give you some context as to what this means. 1/2 of the standard deviation difference. If the standard deviation is 10 points, it's 1/2 of that, or about a 5-point difference. Okay, and once again, using Cohen standards, D of 0.5 corresponds to a medium effect size. These standards were developed. Cohen was very clear, and actually he was a bit hesitant in developing them, because he had said that in developing these guidelines, that is, small, medium, and large for these values, because he was a little concerned that people might just apply them in all cases. What they really are is he found that averaging across a variety of disciplines, that 0.2 is approximately a small effect, 0.5 is approximately a medium effect, and 0.8 is approximately a large effect. But in a given discipline, it may be that these standards do not really apply. They may be too small, or they may be too large. Okay, so once again, keep in mind that these are average these are guidelines that really represent averages across a number of disciplines, and they may not fit perfectly, or they may not fit well at all in a certain discipline, and they may fit quite well in others. Okay, but these guidelines we will be using in class. So 0.2 is small, 0.5 is medium, 0.8 is large.